We are all completely obsessed with making AI more powerful. But what about making it trustworthy? Today, we're going to dig into a new mathematical blueprint that's kind of like a pre-flight checklist for AI, designed to verify every single move it wants to make before it actually makes it. So let's just jump right in with a question that, honestly, changes everything. We're used to AIs that can chat or make a picture. But what happens when that AI can do more? What if it could not just write an email for you, but actually go into your calendar, book a flight, and pay for it with your credit card? What happens when AI can act? And I mean instantly. We're not talking about a slow, step-by-step process. These new tool-using AIs can write and run their own Python code, they can talk to APIs, they can shuffle data around. Basically, they have a whole toolkit and they can use it in the blink of an eye. The potential is absolutely massive, but, well, so is the risk. Okay, so this brings us to our first huge idea, AI with a toolkit. I want you to think of it like this. You're flying a plane, and you've got this brilliant co-pilot next to you who can do amazing things, but it's totally unpredictable. You have no idea how it's making its decisions. And that's the core of the problem, right? How in the world do you trust a black box when one wrong move, I'm talking one single bad line of code, could lead to immediate catastrophic results? You can't just wait for something to go wrong. You have to have a safety check in place before it ever takes the action. Look, this is the absolute frontier of AI development, and getting your head around it is so important. If you want clear, no-nonsense breakdowns of the tech that is literally defining our future, make sure you hit that subscribe button. You're not going to want to miss what's coming next. So, what's the solution? How do we build that safety check? Well, researchers have come up with a mathematical framework to do just that. It's called Certifiable AI Safety Theory, or CAST. And let me tell you, it's a completely new way of thinking about how we keep AI in check. The old way of doing AI safety was kind of like throwing a dart in a dark room. The AI would suggest one single action, and the safety system would just, well, it would guess if that action was safe. It was basically a one-shot deal, just crossing your fingers and hoping for the best, no guarantees. But CAST just flips the entire script. It doesn't look at one possible action, no. Instead, it analyzes the AI's entire probability distribution. That's the full range of all the things it might do, and it mathematically proves that every single one of those possibilities is safe before anything happens. And this visual right here perfectly illustrates the idea. Think of it like an air traffic controller creating a safe flight corridor. CAST draws this mathematically proven safe zone. If the AI's plan is inside that green box, it's cleared for takeoff. But if it's even a tiny bit outside, like that red cross, it's an immediate, absolute no-go. Okay, so you're probably wondering, how does this actually work in a real system? Well, this all happens at a super critical moment called the runtime gate. Just think of it as the final security checkpoint, the ultimate go/no-go decision point, where the AI's plan gets put under a microscope. You know that flight corridor we keep talking about? Well, it has a fancy technical name, a convex safe set. I know, it sounds complicated, but it's really just a mathematically defined boundary. And here's the crucial part. Any plan that falls inside this zone isn't just likely to be safe, it is guaranteed to be safe based on the rules we set. Now, what makes this check so incredibly robust is that it uses this special kind of math called anytime valid statistics. See, normal statistics can get all kinds of confused when an AI starts using tools and creating these messy, unpredictable feedback loops. But these stats, they're like having top-of-the-line, all-weather instruments for a turbulent flight. They give you a reliable reading no matter how chaotic things get. But hold on. What happens if the AI's plan is rejected? This is where CAST gets really, really clever. It doesn't just say nope and shut the whole thing down. It can actually intelligently repair the plan. I mean, just look at the difference here. A traditional system, it just fails. Action blocked, the end. But with CAST, the unsafe action is automatically nudged to the nearest safe alternative. The system doesn't crash, it course corrects and keeps on trucking safely and productively. Let's go back to our flight corridor for a second. This awesome repair job is called projection to safety. See that blue arrow? The system is literally mathematically calculating the shortest possible path from the unsafe idea, that red cross, back to the edge of the safe zone, landing right on that blue dot. So it's not just saying no, it's saying no, but here's the closest safe thing you can do instead. So, what's the big payoff for all of this? Well, it completely transforms our relationship with AI risk. We move from a world of unknown, unlimited danger to one where risk is manageable, auditable even. It's like finally having a complete, trustworthy logbook for the AI's entire journey. This quote from the original research paper just says it all. The goal is to convert unbounded tail risk into quantified, auditable residual risk. Let me say that again. Convert unbounded risk into something you can measure and audit. That is a game changer. So what on earth does that actually mean? Well, auditable risk is pretty much the holy grail. It means you can walk up to a regulator or your board of directors or your customers and hand them a mathematical proof that your AI's potential to cause harm isn't infinite. It's contained within limits that are known, acceptable, and totally measurable. And the safety net gets even better. CAS doesn't just look at one action at a time. It manages a global risk budget over the long run. This is so critical because it prevents that death by 1,000 cut scenario, where thousands of tiny, individually safe steps slowly add up to one gigantic failure. CAST is always keeping an eye on the big picture. So when you put all of these pieces together, what you really have is a new vision for the future of AI trust. It's a system that is finally and truly cleared for takeoff in the real world. And this isn't just some academic thought experiment. This is the key. This unlocks our ability to use powerful AI with confidence in super high-stakes areas. We're talking about automated financial trading, controlling delicate lab equipment, even driving new kinds of scientific discovery. These are all places where you absolutely cannot afford to be wrong. Our whole mission here is to make sense of these complex, world-changing technologies. If you think that kind of clarity is important, then subscribing really is the #1 way to support what we do and make sure you're always part of the conversation. And that leaves us with one final big thought. For years, the entire focus of the AI world has been on making it more and more powerful. But frameworks like CAS suggest that maybe, just maybe, that focus is starting to shift. So the real question is this. Is this how we finally start building AI that isn't just powerful, but is provably, demonstrably, and auditably safe? All right, that's it for this breakdown. We'll see you in the next explainer.